Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.
Alaikum salam wa rahmatullahi wa barakatuh.
First of all, dear Prof, thank you so much for a wonderful presentation. And also, actually, it has been a very exciting moment being in the group. And thank you so much for giving me the opportunity to also ask my question. So I have one question and one suggestion. For the
Okay.
regarding my question, yes. So regarding my question, it's on the aspect that I think you made mention at the beginning of the presentation that sometimes you might develop a model. Then after working with the model at the first attempt, the default mode of the weaker GUI will just give you your maximum results.
Okay.
Whereas if you try to switch to another hyperparameter tuning, or for example, the change, like from example from KNN to SV, small vector machine, you end up having a lower kind of prediction, like the coefficient of our correlation.
Yes.
So in that aspect now, is it advisable for you to continue tuning the support vector machine, or you just choose to work with the KNRS level?
Okay. Okay.
Yes, so that's my question.
Okay.
Then the solution I have for you is regarding the crop model that you say you do in the group in order to like give an enlightenment. So I was suggesting if we can have like a Google form, since we have already attendants that are attending the weekly meeting, so that we'll start putting our inputs before the week will come over, so that at least we'll have a Google form that we, the participant in the group, will have some inputs. And from our little inputs, if there are other data sets available that maybe you might want to use in the prediction, you can use them. But if there are like little data set online, then from our own little input that we have in the group by the participants, I think you can use that to do one or two things.
Okay, thank you very much. That's very wonderful view. I hope it's clear. Let me start from the rear regarding the suggestion. That's a very actually beautiful collection. Suggestion. See, in the world today, we are in the world of collaborative system, and it's always good because, as they say two heads are better than one. Later, they change it to two good heads are better than one. So, whatever being the case, working together as a team actually, which is highly recommended in data science, analytics, and machine learning, is very, very good. I really appreciate that. So that you can have a kind of a crowd source of ideas on a particular thing you want to present. That's very, very interesting. And also having the idea, suggestion, and also if anybody is maybe being troubled by some idea, we feel this thing we would like to these topics to be covered and the likes, it's an opportunity also to let us know actually. So as the case may be. So we're going to look into that, and actually also we also employ for kind of volunteers. So sometimes we might want to do something. Somebody is very good in maybe in a PowerPoint presentation, preparation, and the likes. So volunteers are actually also welcome. So in supporting us to be able to assist people in reaching their goals and as aspiration in their day-to-day engagement, as we try to make machine learning easier for people to use. As I say, it's machine learning for all. So, and I hope that we can all come together to render the benefit as much as possible. Thank you very much for that. Now, regarding your question, which is if you run an algorithm initially and then you are getting good result or very good result or excellent result, so well, do I need to, and I change it to a support vector machine? It depends on what we want to use it for. You just need a system to work for you to make a prediction, to take some decision as a management team. It's okay. Since you have gotten one that is getting you maybe full performance measure, 100%, F measure, 100%. I mentioned it last week. You might be getting 99% in one, in a place, it might not be good because the F measure and other measure are not good. That's why I said you have to check at least two performance measure, like correlation coefficient, root mean square error, before you can decide that you are doing good. If it is classification, check the accuracy. and change the confusion matrix before you can decide that, oh, this is okay. Now, let's assume everything is checked and you feel it is okay for you. You can go ahead and use it. But however, in machine learning research-based system, it's always good to compare. That's why it's good to at least 2 algorithms should be used to solve a problem. So that will give you an idea. Even in discussion of your result, you have things to discuss. Okay, why is this model working? Why is the second one not working? And it's a highly renowned method. For example, support vector machine, k-nearest neighbor might work for you. Support vector machine might not work, actually. So this thing happens. So this is the principle of let the data speak. Let the data speak. So the data will determine which one is going to work, not you. Yeah, but you have to follow the procedure. Now if you get like 75% or 90% in k-nearest neighbor in the default value, I know some people, because of the area, I had a friend, he has always been using statistical estimation like SPSS. So he said he used to get like 40% accuracy, correlation coefficient, and it's okay. So when he got like 75 using machine learning, he was so overwhelmed with joy. He said, wow, this is too much. He wanted to stop. I said, no, you have not done the parameter optimization. You might get more because this is a default value performance. So you need to check for, change it a little bit. Once you start changing from the default, you start getting better one, then try to get to the maximum. Because we have a principle that you have to be fair to that algorithm. So when you report and publish something and you say KNN got 92%, and this is the default parameter value, this is not fair to that algorithm. We might mislead other people who want to read your research later and benefit from it. So that's why it's compulsory. If you know in the presentation today, I put compulsory in front of parameter optimization. So we have to check it out. Can I get better by changing the value to k is equal to 3, 5, 7? If as you are changing it, it's getting worse, then you cannot confirm that, okay, the default parameter, which is k is equal to 1, is the best hyperparameter value. And you can then write it and document for people who want to use this data set of yours. This is going to be the template they should be using. Then for the second algorithm, like I said, if it's just for your own personal consumption in your office to take some decision as a manager, that's okay. Use what is working for you and go ahead. That is if you have gotten 100%, everything is 100, perfect. But if there's still a room for improvement, why don't we try other methods? Like bring in another method or decision tree, do hyperparameter optimization for it, and then see, oh, it's meeting better than the first one, or it's not able to meet up to the second one. Then we can then take a decision that, okay, among these two, I'm going to go for this. But however, to optimize one algorithm and you refuse to optimize the second algorithm, we call it not being fair in research, and it's not going to be acceptable, especially in a standard journal where they do real peer review system. So that's why it's always good to do hyperparameter optimization to be sure this is the best that this algorithm can offer. Because that's what we are saying when you are documenting and disseminating to people. You are saying for this data set, this is the best that this thing can get. Now, if we didn't do the right thing, that means we are misleading the populace, and sometimes they get to know later. It can even lead to recalling someone's paper, that the paper is fraudulent, that we started seeing these days. People are getting their paper recalled, sometimes even students implicating their professor that he asked them to forge the result and the like. So these are some of the challenges that we have to make sure that we follow the principle as much as possible to make sure that we needn't mislead the research community about our output. I hope that clarifies, my brother. Yeah, so number 2, Mr. Mohammed Balogun.
Assalamu alaikum, sir. May Allah reward you abundantly for the great efforts. But like, whenever I attend the class, I'm always happy because I learned new things and it fast-tracked my journey. So the question now is not actually a question. The first one is not actually a question. The last time, sir, the first time you presented the list of all the available resources on the YouTube, when you come under the research, you said that there are some templates that you sent out earlier that will give us freely that we can actually use and get an idea from there. So you said that they will share it in the group, but it has not been shared till now. So I just want to remind you, sir.
Okay, thank you, madam. Thank you.
Yeah. Then my second question is that actually I'm working on a particular problem. So I've been working on it for a very long time now. But I do not dedicate much time to it. But recently I just try to focus more on the problem so that maybe I can actually come up with the result. The data is actually overfitting. At earlier stage, it is giving me a very poor performance on the test result. The training result is giving me like 98%, some 99 like that. But the testing like 20% like that. So I try so many efforts to try to improve the result, working on the data and also working on the algorithm. So I was able to reach like 50% at the point, and also I reached 70%. But the problem with the data, I'm thinking maybe is it a problem with the data? Because I've worked on the data severally and see whether I can improve the. But I also use so many other algorithms. So, but I found out that the three based algorithms, they are the ones that are performing better. So I try to use hyperparameter tuning. I try to tune the parameters, but still the improve is not actually improving much. So I just want to ask, maybe you can give me more idea because it's a regression problem, sir.
Okay. Thank you very much, Mr. Mohammed, for your continuous following up with the sittings. So for your first the first maybe reminder is very much appreciated. I promised to give us this, and I'm going to make it available. I wanted to make a little update on it so that it will be an updated version, but somehow I've been a little bit very busy. So what I'll try to work on that this week before this week runs out, inshallah. If I'm not able to do that, I will release whatever I have before, so that people can start using it. So later, if I have an update, then I will provide the update so that the people are free to use it. So it's a format. So now you want to write your machine learning report or paper, you just follow the format, so it should be fine for us. Thank you very much. Then regarding the question of one, so once the procedure we've identified today is followed, get your data set, put it, start with something simple. The principle of machine learning is we make it simple. Start from simple algorithm, and I think that's what we are doing. K-nearest neighbor decision tree before you start going to complicated one, because sometimes the small one we cache the information in the data, but the bigger one might not be able to catch it because of the nature of the data. It's not always the harder the better. No. So it's like somebody who want to kill a fly. You decide to go and take a big hammer, a big stone to kill a fly. You might destroy your table, and at the end of the day, the fly might still escape. You just need a small broom, very small, to take care of the case. So this is why in machine learning, there's a principle that you should start with the simple algorithm first. So once we have tried a couple of algorithms, you have done the hyperparameter optimization, and yet you are not getting what you wanted, then it is time for you to start looking at more sophisticated algorithm, like support vector machine, neural network. And if all fails, because sometimes no matter the algorithm, it may be that the data is complex. Let the data speak. The data is communicating, but the algorithm is not able to understand the complete communication with data. In that case, you need to use the power of group. That is, you need to train ensemble system. Train like multiple k-nearest neighbor, those that are performing, train multiple. KNN when K is 1, KNN when K is 3, KNN when K is 5. Train those ones that add appreciable performances, and then come up with ensemble system. Either voting ensemble, or you want to do stacking. So this might be what you need. You can quickly use random forest, which is ensemble of decision tree randomly created. So check out and see, maybe perhaps hybrid ensemble might actually be what is going to understand the idea of the data set. However, depending on how complicated the data is, there are some data sets that are just very hard. No matter what you do, then maybe 75% might be what you need. Then in that case, we may have to look inward to get more data set. Maybe the attributes that are being used, they are not very relevant. Because if the attribute is not relevant, there's no way we can get 100%. Even after hybrid or after ensemble, several ensemble, we can still not get it. In that case, we have to review the data collection process. Maybe we need to add some useful variables that are not there, or we might have to actually look inward to say, okay, how can we get this problem solved? For example, there's something we call it here, and it's better to have a smart data than looking for a smart algorithm. You see, when you have a smart data, you can get a lot of things done. Smart data, the data is very, very smart. It means the data is clean, there's no problem with the data, but sometimes we don't have control over the kind of data set we are going to use. So in that case, we are kind of practically stuck with what we have. So try all those procedures of itemize, try ensemble, so hopefully you will get something better. And then you have to also look at, are you the first one to use this data set? If people have used it before and they claim to have gotten huge, better result than you are doing, then from my experience also, you have to check. Not all paper, unfortunately these days, you can't rely on all the paper published. Some paper are published in junk journals, with due respect, where they don't do peer review. There's no experiment done. They just formulated the result. So you just be troubling yourself, try to beat them. How can you beat somebody who has not performed an experiment, who just manufactured data? So this is why data falsification is a serious threat to academic integrity that needed to be seriously curtailed. So also, you might also need to get maybe a couple of that feedback. Use normalization, normalize your data. It could also help. Do feature selection. These are other suggestions that might actually possibly help you in improving the result you are getting. So at the worst case, we might want to seek for private consultation later, so that we jointly look into the data set and see what can be done. Hope that benefits. Wish you all the best.
Jazakumullah khair, sir.
Barakallahu. So, okay, we still have two people. Okay, Mr. Cyril and ye, Dr. Cyril. How are you? You have the floor.
Yes. Good morning, Prof.
Good morning. How are you doing?
Yeah, I'm fine, sir.
Okay.
Thank you for the lectures.
You're welcome.
Yes, it's always inspiring.
Thank God.
Unfortunately, I really struggle to come join you, but anytime I join, of course, I have a lot to take home.
Thank God.
So,
feedback.
Yes, sir. I actually want to ask for some of us who are not really having computer science background. So, and maybe somehow we developed interest in following up with what you guys are doing. So, I want to ask, would there be a time probably, or maybe that had happened some of the times I wasn't following, would we have a situation where we have like a case study of a problem and then we follow it to the end and see how some of these things are, how we navigate through some of these processes in a, just to, because I mean, to learn from the expert, like you taking us through, oh, this is a case study, this is what happened, this is what I did, this is how we fixed it, and stuff like that.
Yeah. Okay. I feel landed. It's okay. That's your question. Okay. Okay. Thank you very much. Yeah, we actually it's very interesting that you actually took note of that. It's one of the very good way of learning. And we've actually we did a couple of one before. Yeah, we've had a few case studies. So where we pick up a kind of a proof of concept of a new idea, and then we actually show the published work in this area, how we started it, how the data were collected, the processing, then every stage, and also even I believe that if we check out one of the video description we made last week or so, under the researchers corner, we see sample presentation on case study of papers that have been published. So we took I remember we discussed what do we call this, anxiety prediction during COVID-19. Anxiety prediction during COVID-19. It was a very spectacular paper. So that data set were developed. It was a questionnaire to gather data to be able to predict if somebody is having anxiety, so that they can be able to attend to that person before it gets out of hand. So we look into that paper in detail. I think we also look into Alzheimer's disease preemptive prediction. So we treated like maybe 2 or 3 case studies. So we hope we are going to be able to again have another time an opportunity to treat even more case studies. So well noted, but we can check out the one we did before on the case study on some of these example. Just download, get the WhatsApp guide document, just search for it. Just search for case studies or search for published paper descriptions. You will see them there, and then you can check the video out and then see how we carry out the case study description step by step, and how the result and discussion were carried out. So thank you very much. I hope that's answered your question.
Yes, thank you so much, Prof. I'll go to the videos and check it out.
Okay. So please go
Yes,
there, check it
if
out.
I have any more, if there's any other thing, then I'll contact you personally.
Yeah. Feel free to always contact, feedback, and like
right,
I said, whatever we feel we needed, so just communicate appropriately. We try to put it in our to-do list. So hopefully that we're gonna have one opportunity to also look into such thing. Thank you very much.
Sir. Thank you.
The last question I did for the day, because of our time, is Mr. Salami Hamzat.
Assalamualaikum, sir. Assalamualaikum, my prof.
Salam, we can hear you. How are you?
Yeah. Yes, sir. I am fine. I'm fine. So it's always a pleasant time to have you. So we really appreciate your impact in our life and in our research journey. Yeah, Prof, I don't want to take much of your time because you have spent enough today. Sir, yes, I'm from economics background, and so far you have done justice to what? An aspect of machine learning called classification, which is similar to our cross-sectional analysis in economics. From what we have learned so far, it's machine learning classification analysis as surpasses what we do in economics. It's kind of a big advancement to us in economics, which we really appreciate all we are learning from you. But in the area of regression of machine learning, we have not done enough. We have not done enough, and that's the reason why I was like, okay, let me like put to your notice little things we do in economics using our econometric analysis, our econometric platforms such as eView, Stata. If a time series is to be carried out, we do a pre-regression analysis such as stationarity test, co-integration test, and so on, to enable us to know the kind of model that we should develop. And also, if an issue of endogeneity comes into. Also, we do support. We give us a clue of a model to be developed, such as a vector auto regressive model and so on. So this has been giving us an insightful result that has been helping our analysis. In the face of machine learning, how does all these things play? How does all these things play? Do we also have to carry out the process we do in economics? So I want your insight, so that at least if we are to carry out a regression analysis using machine learning, we should be able to tell our colleagues that yes, this is the strength of machine learning to regression analysis compared to what my colleague and I are used to. Because now I can tell them categorically that when it comes to what classification analysis, this is the superiority of what of machine learning compared to what we are used to. Please, I also need that authoritativeness in regression analysis. I would appreciate if you can just come in a little bit to give me some nerves to challenge my colleagues in economics, sir.
Thank you very much for that. I know you have been consistently following these sittings and the channels. Yeah, you have succinctly stated the reality. The obvious thing is that the uniqueness of machine learning, and that is why when they say machine learning is the next internet, when you say something is the next internet, that is the next thing that will check the world, the way the internet changed everything. I was having a presentation seminar for a student a few days ago that when you say machine learning is the next internet, just imagine before internet came, during my undergraduate there, I remember we used to talk about e-commerce. It was theoretical. What is e-commerce? How do you sell something in the space? But today it became a reality because of internet that people don't have any store. They're making more money. Just write an application, and then you can order for something on their application. They're going to contact the shop. The shop will package it and then send it to you. These guys are not doing anything, just the application. Today, they are the ones that are having the money. They give the remaining change to the owner of the store. That is, internet revolutionized the way we do things. You see, banking you want to think of? So in the same way that machine learning is expected to revolutionize every facet of our endeavors. So regarding the classification, it's very clear because you have done a lot of things there. Yes. For regression, actually, it's the same thing like classification. There are a lot of cumbersome procedures that we do in the either econometry. I have one of my friend, a professor, used to say it. There are a lot of things you do manually to support the regression, because regression analysis compared to machine learning, the gap is wide. For example, in permeability prediction, this is oil and gas problem solving. Permeability, they need to know if a particular reservoir or oil well will support the flowing of the oil before they dig it. So we need to establish permeability. So they were using the regression analysis before, equation of states, but the performance was very low, 40%, 30%, 35%, 45%. With the coming of machine learning proper, they started having 80 something plus, 90 plus, with integrated ensemble hybrid with fuzzy logic. The last I can recount, we were getting 99%. This is predicting number regression, 100% performance. So which to the regression world, it was impossible. And then there was a paper recently published on soil contamination modeling. The professor we worked together on this is one of the papers of itemized, hopefully in the soon. Later, we are going to discuss the case study of this paper to also follow what Dr. Cyril actually asked. It's on regression. How can we determine the contaminant in soil? So the prof used to do it using other regression analysis. You know, in regression analysis, the concept of training and testing is not even there. Yeah, it's not there. But machine learning will have a case whereby you are going to train, and then you are going to keep something totally not seen before, and you expect it to give prediction value for you. This is a very unique capability of machine learning. As it is in classification, it is also in regression problem. The only difference is in what they are generating. Classification is generating categories, class A, class B, while regression is going to predict exact exact number, exact real value number you are dealing with. So in this sense, the same thing you can boldly and categorically stated that happen in classification is also happening in regression. In fact, some of those procedures you mentioned, this and that, they are meant to support regression because regression analysis is weak compared to machine learning. So you have to do some other stuff to be able to interpret your result. But with machine learning, you do it at a go. It takes care of everything, like collinearity, all those kind of things that you have to do compulsorily. Machine learning takes care of that. You see, the worst case, we're going to do what you call feature selection to finish everything as the case may be. So what I would suggest is for you to try to get a regression data set. Get a regression data set. Try to use whatever regression analysis you are using and now come and train it on the Weka. You are very used to Weka now. Do training and testing using any of the machine learning algorithm. Compare the result you are going to get from regression and the machine learning point of view, so that you'll be able to see the uniqueness that machine learning has brought on the table regarding regression problem. I hope that clarifies. So
Yes, thank you, Prof. I'm happy. I thought I'm very, 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 very grounded now, and I'll do exactly what you have suggested, sir. And I'll probably private chat you, sir, of my results. Thank you. I really appreciate it.
okay, thank you very much. You are welcome. Somebody say, is there any program for undergraduates? Well, as a matter of fact, the good news is machine learning does not push anybody aside. Undergraduate, postgraduate, you're all welcome. My postgraduate students are publishing papers because of machine learning. Usually before, people thought undergraduate students cannot publish. But with machine learning, they can do a lot of powerful analysis, which they couldn't have done as an undergraduate. Or machine learning will do it for them. They just need to click, know the procedure, and then they are done. So you see undergraduates these days are publishing paper, even though they are not yet a researcher, but then it gives them the opportunity, the upper hand, if they have to apply for research funding or for postgraduate in future. So as an undergraduate, you're all welcome. I think we have a couple of undergraduates also in this sitting and also in our WhatsApp group. So provide your number. So my admin kindly take care of the person, Abibullah. So let him add him. The number is there. So add him to the forum. So either undergraduate or postgraduate, you are all welcome. So yeah, thank you very much. So whoever want to contact me, yes, you can always contact me. But please don't say you contact me on WhatsApp. If you don't get my response immediately, do feel free to forward that to me sometime, because I have so many messages, I might miss your message. But everybody is welcome to contact. We also implore you to please help us disseminate to your people. Our intention is to let it go as far as to people so that people can benefit a lot. So in the past few weeks, we have noticed that a lot of people are getting to know about it. Thank you very much, and I wish you all the best.